Hi all, welcome to part 5 of the video lecture on counters. So now we are going to see the generalization of what we've seen so far. So what we discussed so far is just a single toggle flip-flop, T flip-flop in toggle mode, and we observed that its output is something like half frequency of the input clock, right? So that is what we've seen. Now what we've seen is divide by two device, right, which can divide the input frequency by 2. Now the question is, can I divide the input frequency by some power of 2? It can be divided by 2 power 2, that is 4, divided by 8, divided by 16. So we are interested on division of the input frequency by some powers of 2 only. So can I do that? So the input frequency, if it is f hertz, how to generate another clock of frequency, say f by some 2 power k hertz? So that is frequency division by some power of 2 is what I am interested in. Okay, so let's start with the circuit which can divide the input frequency by 4. Okay, so it's very simple concept. Like if you understand the concept that I discussed so far, this you will understand very nicely. So what I was trying to say here, I have the clock, right, and the T flip flop, the first T flip flop that is connected in the toggle mode, and you know that this output, if you are observing this output, you can see that if the input clock is of frequency some f hertz, you will get its output as a clock of frequency what 2f, not 2f, f by 2, it's dividing, right? So this is something f by 2 hertz. And why it is so? Because if this is of time period t, we can see that, and we observed it in detail, right? This is of time period 2t. Okay, so that is what we see. Now what I am doing is I am just using one more T flip flop. Okay, one more T flip flop. Let me connect, because wave I go on. See, I don't want this much bigger wave. Okay, this much is fine. So now what I am going to do is I am just taking one more T flip flop, same T flip flop, okay, and the T I am fixing like this. Now what about its clock? So instead of applying the clock simultaneously, so then it will be asynchronous counting and all. So what we are discussing is asynchronous device. Okay, so I already told you, for asynchronous counter, the output of the first clock cycle will be connected as the input clock to the second, and there is no common clock to all. So this is the kind of configuration I am having. Okay, let's see what will happen if I am connecting like that. So this output of the first T flip flop, this is my T flip flop 0, and this is my T flip flop 1, so that this is the output to Q0, and this Q0 I am connecting as the input clock for the second one. Now tell me, what is your Q1? Okay, it's interesting, right? What is your Q1? So don't think about this circuit and all. I have a T flip flop. Just imagine this, just look at this single T flip flop only, don't look at the other one, and you know it's working. I have a T flip flop for which I am applying a clock which is a frequency f by 2 hertz, whatever it is, or some 2t, this much time period and all. Definitely this T flip flop is going to divide that frequency further by 2, right? So that is what we seen. So you will get something like this. Anyway, I am not able to draw the perfect square wave. You assume that it's a perfect square wave, right? Okay, I am just drawing. That's all. You can see that if this is 2t, this will be double of that. That is what I mean, 4t unit of time. So that the frequency is now f by 2 by 2. That is f by 4 hertz. Is it clear? Okay, and if you are not clear, let's see the timing diagram. It will be very much clear for you. So this is a diagram, what I mean, and now I am going to see, I will explore what is a clock. Okay, so I will take some clock, like some small, okay, I will take some clock signal. Okay, this is what I am planning, and then I will see what is my Q0, then I will see what is my Q1, and I am saying that you can see that you will get this Q0 as something like this. I mean 2 times of input period of this, and Q1 will be something like this also. This is what I want to verify. Okay, so if that is the case, if this is a frequency f hertz, this will be a frequency f by 2 hertz, and this will be a frequency f by 4 hertz. Let's verify this in the next page. So what we need is We are just taking the clock pulse like this. Again, the drawing part I'm not good. Anyway, yeah, let's draw the clock like this. What I'm trying to draw is a perfect square wave, okay, even though it is not perfect, sorry for that. You assume so, with some frequency f is shown. Okay, fine. Now what I need is, I just want to observe this during every not here, because it is positive edge triggered, right? So you can see the clocks are positive edge triggering. So same thing you can analyze for negative edge triggering also. You can try in your own way. See, the positive edges are highlighted here. And during these positive edges, let's see the outputs. Okay, it's fine, you continue. So this is our clock, and let's see what is my Q0. So Q0 is the output of the very first flip-flop for which the clock is directly connected. You keep that in mind. So Q0 is the output of the flip-flop for which the clock is directly connected, okay? So that will trigger in every positive transition, right? So assume that it is starting with a low voltage, so that now it will toggle and it will continue, and this concept you all know already, right? Now again in the rising edge it will toggle, it will continue, again here it will toggle, it will continue, here it will toggle, it will continue, here also it will toggle, it will continue, like that. Now this wave form is what I am applying as the input to the second T flip-flop, okay? So keep that in. So Q0 is coming as a clock pulse for the second one, so that the second one will be triggered during the positive transition of this particular clock, because both are positive edge triggered. So during positive transition of the clock edge, these flip-flops are going to be triggered. So second one output I am observing, if I am observing the output, that will be triggered during this positive transition, because output of the first one Q0 is what is connected as the clock signal for the second one. And repeating again and again, I hope you are getting an idea. Assume this Q1 is also initially 0, so that is my initial assumption, so that it is changing like this, and now it will continue this high till this, because during the next positive edge only it will be triggered, and that time it is in toggle mode, it will toggle, right? It will continue this like till this. Now it will toggle, again it will continue like this, okay? That's all. Now if you have one more connected, so now you can generalize the concept, right? Let me tell you that. So what I was trying to say is, if this original wave is of f hertz frequency, this one will be of some f by 2 hertz frequency, and this is of some f by 4 frequency. So I got this division by 4 when I connected 2 flip-flops, right? Now assume that I have a third flip-flop. So third flip-flop, what I was trying to say, so this is a modification I was trying to tell you. Let me try to take a copy of this page, copy current. I don't know whether it will do that. Sorry, it's not doing that. Okay, if something is there, it will copy. Yeah, anyway, what I was trying to say is, I'm having one more flip-flop. Say, what is this? This is my flip-flop 2. Its output I am denoting by Q2, and its T I am fixing as 1. And what I am doing is, this output Q1 I am connecting as the clock pulse for this, and I am observing this Q2. So if I observe this Q2, you will see that this Q2 is going to be triggered during the positive transition of the input to clock, and that input to clock is nothing but this Q1. So it will be triggering like this during positive transition. It will it will toggle, and it will continue this until the next positive edge, and that time only it will trigger next, okay? So at this point it will trigger next, means it will toggle further, and it will continue like this. Now you can see that if you continue, this is something, this f by 4 by 2, that is f by 8 hertz. So like that you can keep on connecting flip-flops, and you can divide the frequency. So let me tell you the final conclusion. So what you done here is, when you are having one T flip-flop, frequency divided by 2. This is what we see initially. Okay, now when you connected two T flip-flops, first one given me frequency by 2 and the second T flip-flop given me frequency by 4. Hope it is clear, right? Similarly, using 3 T flip-flops you can achieve frequency division by f by 8. And what is this 8? F by 2 cube, and this is coming like that. Okay, now using 4 T flip-flop, and you should understand how these things are connected. They are connected in a cascaded manner. 4 T flip-flops are there. First one will divide the input frequency by 2, second one will divide the input frequency by 4, third one will divide the input frequency by 8, and the fourth one will divide the input frequency by 16, and this 16 is nothing but 2 power 4 heads, like that. Okay, now you can generalize it. If I am having some k T flip-flops, I will be able to divide the input frequency by some 2 power k. So this is how we are going to divide the input frequency by some power of 2. So if you want to divide by 2 power k, you need T flip-flop, and the very first one for which the clock is directly applied, the output will be or input frequency by 2. Second one it will be input frequency by 2 power 2. Third one it will be by 2 power 3. Like that, for the kth one it is original frequency by some 2 power k. Yes, hope it is clear. Maybe what happened. Okay, so this generalization is clear. I hope it is clear at this point. I added some more slides, but it is missing. Anyway, we will stop at this point. Okay, so hope this concept is very clear, right? Now in the next video we will see how this will act as a counter, and that is interesting. Now I hope you got an idea about that counting. So here we are seeing that frequency division part, and this only we have to observe in a different angle, and that time you will understand that this is some modulo 2 power k counter. Okay, and that visualization we will have in the next video. Thank you.